will get to understand where to use, where not to use these layers. So this is a 4 hidden layer unit with corresponding to the simple RNN architecture. And at the end, obviously, we are going to be used as softmax because it is a classification task. And you can see the compile after this is just a you can say this is just a representation of your neural network. If you try to understand from the yesterday's point of view, we just represented as a input layer or input node along with some of the hidden layers and output, right? So this is how we created a neural network model. On top of it, we are just going to be compile it. They're just going to perform. So we have done in the classical ML to represent any kind of the model to try to fit, right? Fit and transform with corresponding to the extend and also the wide trend, so that all the results will going to be fit and transform with respect to that, and then it's going to be learned from whatever the model you're going to be given. So that's what we are doing here. Similarly, the compile with some activation functions, you can some optimizers we are going to be passed. We're going to be learn optimizers maybe after boosting mechanisms whenever we implemented then it's very easy to understand. And then also loss function, which loss you want, whether it is a cross you can say log loss or also the categorical cross entropy or binary cross entropy. You can showcase which value you want to be showcased with respect to the epops you want to be represent at the time. And model evaluation, if you want to perform F1 score or the accuracy results, that's your wish. So yeah, just fitting of the model, X train and also the Y train with the number of epops. Epops we already know, right? One round of the forward and also the back propagation. So then batch size is going to be mentioned. Each time it's going to be passed 16 new, you can say 16 neurals or you can say 16 nodes at a time. So that's how we can also discuss this batch size. How does it going to be helpful? And yeah, this is how the history and this is how the epops going to be learned and compute the result along with the train and also the test results. If you go and see the loss, it's slightly going to be sorry, this is the accuracy and this is a loss. The loss is slightly going to be decreasing somehow, and some point it's also increasing, and some point is increasing and slightly also decreasing. You can see the loss might be come down slow whenever you have number of epops are increasing. This is the number of the epops, whatever the epops we had, 100 epops. The loss is slightly decreasing whenever epops are increasing, right? And accuracy also, you can say whenever the epops are increasing, accuracy is slightly going to be increasing. The 100 epop, it's a maximum or global maximum, we can also call it as. So if you go and see the loss is very narrowed or very global minimum point reaching at 65th epop. So what will happen if you reach like kind of these things for a larger data sets? It will take tons of time, right? It will completely waste of your time at that time. And also you had a requirement called low latency. You have to remember every time. I had a requirement called low latency. Low latency, we are going to be showcase these kind of the models into the production environment. No one is going to be accepted. No one is going to be accepted your model. So at this time, this is a issue or a problem to showcase in your perspective to optimize your model. Obviously, you're going to be optimized. Otherwise, no one is going to be accepted. So you can see this is the global loss you're going to be get, and this is the global accuracy, just for simplicity to understand. But what will happen if you showcase as a 60 epop or 65th epop to learn any kind of the neural networks? It will take maybe 1 hour or 2 hours for large number of data. This is very small data set. This is very small data set. This it still not be worked out according to this kind of neural network. If you apply, we applied only 4 hidden neural networks, right? 4 hidden neural networks with somehow some optimization called Adam. So this is also going to be helpful for the computation efficiency, I can say. But eventually what will happen if you apply these kind of the large data sets? It will take maybe the 1 hour of maybe the 1 hour 1.5 hours also to run this 6050 pop. So what will happen, we have something called as a tensor board. So this tensor board is going to be helpful whenever whenever you need to play around with some of the loss and also the accuracy and also some of the other parameters you are going to be showcased in the tensor board. So what you need to do, we have some checkboxes and we also slide bars, according to the tensor board they developed by the Google. We have some slide bars. So in this slide bars you can drag from the left to right and also the right to left, so that you eventually look on how much epops or how much epoch is going to be trained to get less or minimizing loss. So this is one hack, I can say this is a minimizing one hack, and then you can run up to the epoch. So this is one hack I can say to optimize your model. And second hack is something called as early stopping. So what you have to do, whenever you eventually is to stop, whenever you suppose you're going to be loss minimizing this kind of the thing or minimizing this kind of the thing, at the time you learned previous timestamps or at the time you learned from the previous losses what you had, and also the accuracy results, how much accuracy you got. You can see here this kind of the thing it's going to be learned together. So whenever you lost something or accuracy is very less, it's another less is going to be high, right? So somehow it is going to be increasing. So at that time what will happen, early stop does, it's going to be stop in this step, it will stop in this step. So at the 21st EPOP, you're going to be get as a good amount of accuracy results. But nonetheless, you can say this kind of the accuracy results may not be satisfied with the global maximum result. This is a global maximum. This is also global maximum result. May not be satisfied. Somehow small difference, maybe 1 or 2 percentage, but this is okay. Achalta, you can say in terms of the practical machine learning are going to be applied in the production environment. But what will happen eventually take this kind of the early stopping mechanisms or the tensor flow. So we have so many other hacks also, but as per we can also go through these kind of the hacks in the future classes, so that you eventually got some idea according to this. You can also predict by using whatever the different classes we had, and you can see the somehow loss and also the model evaluation is going to be get. The loss is slightly better, and also the accuracy, because since it is a very small data set. Let's predict our model which is going to be works out or with the RNN, simple RNN. Yeah, so I'm just passing this random data set with corresponding to the sine wave. Let's all predict this. What exactly the actual data set and also the predicted data set what we had. So yeah, it's predicting correctly. Similarly, in terms of the squared also, you can see the squared. We just given some point here, just showcasing the points to predict. Similarly, it's going to work out and along with the triangle also. So this is very simple data. So you can also play around with the iris data set what we learned. That is also three class classification setting. So if you understood these concepts in terms of iris data set, that is also very helpful. But you eventually cannot get loss of 0.19 as per discussed in these notes. But eventually you get around point 0.35 like this, maybe point 0.3 or point 0.8 like this. So you can also try this according to your, and also you can learn from the 100 epops. Maybe you can learn 50 epops as per the iris data set. So take some large data set. Maybe you can take from the UCI repository or the Google data set. That's also very helpful in terms of to understand. So let's jump on to the other concept maybe. So we have something called as the transformers and also called as a sequence model to represent any kind of models in the NLP context. So let's also try to learn in terms of the NLP context with respect to the sequence to sequence models. So the sequence model concept came into the picture of these two different terminologies. So one is the encoder and also the decoder concept. So I will literally going to be explain what exactly this does and what are the different terminology we are going to be used. I'm not going to the details of it as of now. I'm just going to introduce some of these concepts. Then we can also focus more on the LSTM and also the GRU concepts with respect to whatever we learn in the RNN part. So I'm introducing these sequences